Welcome to Chapter 13. In Chapter 13 we are going to solve equations that have equal signs in them, also squared terms called quadratic equations. There was a little bit of this in the review assignment around questions 17, 18, 19 that we did in class on page 497. However, we're going to see trinomials in these problems, which means we're going to have to factor by grouping, so there'll be a review of that. A quadratic equation is a polynomial equation of degree 2. An example would be something like x squared plus 4x plus 3. And we set that equal to 0, and it becomes an equation that can be solved. You'll remember that we factored this by creating the puzzle. Things that multiply to be 3 add up to be 4 are positive 1 and positive 3, and we use that to factor. So we're kind of doing that sort of stuff, and it might not be a bad idea to go back to chapter 11 and take a look at that video in how to factor trinomials. We're going to solve quadratics by factoring, and then because the product of the two factors is going to be equal to 0, we'll set each product individually equal to 0. It's a pretty easy process. If you can factor, solving them is pretty darn easy. We're going to get two baby equations that, when solved, give a solution to the problem. These answers are called roots. That's not the first time you've seen that vocabulary term, root, and we're going to hear it a lot in this chapter. Later on in the chapter, we're going to do some graphing. We're going to learn how to graph these equations. But for right now, let's solve them. The first step is you have to set the equation equal to 0. Set the equation equal to 0. And each problem is going to be kind of its own animal like that. Some of them will already be set equal to 0. Some of them you're going to have to manipulate. So in this particular case, I got to get that 2 to the other side. I'm going to add it to both sides. Negative 3x and 2 are not like terms. So I get x squared minus 3x plus 2 equals 0. Now, I'm going to take my puzzle. I'm looking for factors of 2 that add to be negative 3. That's negative 2, negative 1. So I get x squared minus 2x minus 1x plus 2 equals 0. I'll take an x out of the first term. I want x minus 2 in the parentheses when I factor the last two terms here. So I'm going to take a negative 1 out. So I'm left with x minus 2 times x minus 1 equals 0. I can now FOIL these two terms back together to check my work. Now, here's what's new. You'll notice that's set equal to 0. If the product of x minus 2 and x minus 1 is 0, one or both of them must be equal to 0. So I'm switching to orange here. This is what's new. I'm going to take x minus 2, set that equal to 0, solve for x. X is positive 2. I'm going to take x minus 1, set that equal to 0, solve for x. X is equal to positive 1. Those are the solutions. If I want to write it as a solution set, I can write it as x is a member of the set with 1 and 2 in it. And there it is as a solution set. Let's take a look at problem number 2. First thing I'll do is I'll add 10 to both sides to set this equal to 0. X squared minus 7x plus 10 is equal to 0. I'm going to do my puzzle. Factors of 10 that add up to be negative 7 are negative 5 and negative 2. So x squared minus 5x minus 2x plus 10 is equal to 0. I factor an x out of the first two terms. I factor a negative 2 out of the last two terms. I factor an x minus 5 out of these two terms. So I get an x minus 5 and x minus 2. That product is equal to 0. Now I make what's called a t-chart. X minus 5 is 0. I'll add 5 to both sides. I get x equals 5. That is one of my solutions. I take x minus 2. I set that equal to 0. Add 2 to both sides. I get x is equal to 2. Let me pause this for a second and I'll try to figure out where that screen just went. Alright, sorry about that, folks. We got everything kind of back where it's supposed to be. We have x minus 5 equals 0. We add 5 to both sides. You get x equals 5. That's one of your roots. X minus 2 is equal to 0. We add 2 to both sides. You get x equals 2. And that is your other root. All quadratic equations have two solutions. You could have the same number repeated. Those are perfect squares where that will happen, but in general, that should be the case. All right, take a look at number 3. We have 2x squared equals 3x. So step 1, set the thing equal to 0. I'm going to subtract 3x from both sides to do that. 2x squared minus 3x is equal to 0. How do I factor this? It's not a trinomial, so it's either going to have a GCF or it's different to two squares. Start with GCF and see if you can take anything out. You'll notice that there's an x. 2x minus 3 is left over if I divide both terms by x. Now I go right to the t-chart. You'll notice I switched to orange for my t-charts because that's what's new. I'll set x, set that equal to 0. I'll take 2x minus 3, set that equal to 0. I'll add 3 to both sides. You get 2x equals 3. I'll divide by 2. X equals 3 halves is one of my roots. The other root is actually x equals 0. So if you plug 0 into this equation, you'll notice it does check out. So in set notation, I can put 0 and 3 halves in here if my answer has to be in set notation. That's just curly brackets. For number 4, before I move that 9 over, I'm going to clean up the left side. I'll use the distributive property. X squared minus 6x is equal to negative 9. I'll add 9 to both sides. X squared minus 6x plus 9 is equal to 0. Now at this point, we are going to factor the trinomial. So I'm looking for factors of 9 that add up to be negative 6. That's negative 3 and negative 3. So I rewrite this. Factor out whatever's common to the first two terms. That's x. Factor whatever's common to the last two terms. I'm going to take a negative 3 out of that, because remember, what's left over in parentheses should be the same thing as the first set of parentheses. I'll scroll down a little bit. X minus 3 times x minus 3 is equal to 0. Now you'll notice the factors are exactly the same. So in my t-chart, it would be a little bit unusual to make a t-chart and have x minus 3 equals 0 in both of them. However, for the purpose of this exercise, I would do it. Typically, I don't think I would. I'd probably skip that and just do one of them, because there's only one answer. I said quadratics are supposed to have two answers, so what's going on? Well, you'll notice you get the same answer 2 times. So there is 2 answers, but the answer is x equals 3 2 times. So you can list them, but really you only have to have one x plus or x equals 3. There's really just one of them. All right, number 5. Now these problems are getting more complicated, but the basic stuff here is you have to factor, and then you take the two factors and you make a t-chart. Here we see a proportion. So I multiply x times x plus 2. Here I'm going to multiply 2 times 12. I distribute. X squared plus 2x is equal to 24. And now I can do what I did on the last screen. Subtract 24 from both sides. And there's your trinomial. So now we do the puzzle. Factors of negative 24 that add up to be 2. So let's see. 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. In order for us to have positive 2 down there, I'd have a positive in front of the 6. That 4 is going to be negative. So I replace my 2x with negative 4x plus 6x. And then we start factoring by grouping. I'll take x out of the first two terms. I'm going to take 6 out of the last two terms. And then I'll factor x minus 4 out of these two terms. When I make my t-chart, use some of the space over here. I have x minus 4 equals 0. So if I add 4 to both sides, you get x equals 4. X plus 6 equals 0. X equals negative 6. And those are your solutions. So x equals positive 4, x equals negative 6 are your solutions. Now, problem 6 is a question right off of the chapter review. So you do not have to go through this process to solve it. We're going to take the square root of both sides just like we did. We'll say x is equal to plus or minus 3. So when you are facing a problem that you have a technique for from a previous section or a previous chapter, don't throw those techniques away. You go ahead and take the square root of both sides. But just remember, two roots. You have to have a plus and a minus in front of that 3. Alright, let's see what else we have here. Looks like we're to our homework. That means we're done. I would strongly suggest going back to chapter 11 and looking over that factoring lesson. Maybe watch it again. Maybe look at the factoring completely lesson. Both of them are around 10 minutes. Making sure that you are comfortable with that work. That would only help you in chapter 13. This is going to be our last chapter of the marking period most likely. So we want to do well and keep riding the wave. Have a great weekend. Oh, I'm sorry, this is Monday night. Have a great Monday night. I will see you on Tuesday.